Hi, welcome to the Calculus 2 lecture series. And we are in unit number 2. We talk about the different techniques for the integration. This will be the second video for the lecture number 9. And we use the partial fraction method here. And from the first video, we talk about what is the partial fraction, and when we have a rational function, how do we break it out to the partial fractions here? Okay, so now today for this video, we are going to take a look how to really solve the problems here. So let's go back to our worksheets here. All right. So, okay, so if kind of refresh your memory, this is what we did on the first video. We talk about what type of the, for the rational function, the denominator, what type of the QS, and how do you write it out for the partial fractions. And then we did the 4 problems, and these 4 problems, we did not really carry out the calculation, we just break it. And so we did these 4. And so now for this video, we're going to physically carry out what, how to do the partial fractions here. Okay, so now let's take a look at the first problem here. So for the first problem, this is x cubed, right? So here, this is x cubed. Then the bottom is x minus 1. So we know the first things here, if you remember, this is the steps we talk about how to do that. So if we say, if the rational function, the numerator is the degrees of numerator's polynomial is greater than or equal to the degrees of the denominator, then we need to use long division to reduce the degree for the top of the rational functions here. All right, so here, let's take a look in here. So now in here, the top is x cubed plus x. So now let's try to use the long divisions, right? So the long division, we start at x cubed, save space for x squared, then plus x. Okay, so this is x minus 1. So remember how we do the long division? So we want to match the first ones, right? So what do we have here? So it's x squared. So x squared times x is what? X cubed. Then x squared times negative 1 is minus x squared, right? So that's why I'm leaving a space for that. Then I'm minus these things out, and then x cubed minus x cubed disappear. So 0 minus negative x squared. So what I have is x squared plus x. Correct? All right. Now, here, this is x squared, this is x. So what I need to do, I do x here, right? So it's x times x give you what? X squared. Then x times negative 1 is minus x. And what is over here? X minus negative x is 2x. Okay, so if this is 2x, then here what I need to do, plus 2. So it's 2 times 2 is 2x minus 2. Okay, then you 0 minus 2 is 2. All right, so now I know that after the long divisions, I can take this part out. So this whole integration will just be equal to the x squared plus x plus 2 and plus the remainder, right? So this is so what is this one? This is the remainder terms, correct? So the remainder term go to here, then this is x minus 1 dx. Then we simplify the fractions, the rational function into a function. I know how to integrate. So x cubed, I use powers rule. So this is x squared, so it's x cubed over 3. Then plus x, this is the first power, right? So this is x squared over 2. Then plus 2x. Then what is here? This is x minus 1, the 2 over x minus 1. So what is here? We know the natural log was integrations, right? So this will be the natural log x minus 1 and the plus c. All right, so it's a kind of this one is a pretty easy here. Okay, so now let's take a look. The second one is here. The second one, this is x squared plus 2x minus 1, and this is 2x cubed. Okay, so this is x squared, and this is x cubed. So the degrees of this one is less than this one, so we don't need to do the long division. So we don't need to do a long division. Then let's take a look. Can I simplify the bottoms here, the denominator? So this is 2x cubed plus 3x squared minus 2x, right? What I can do, I can take the x out, can I? Yeah. So this is 2x squared plus 3x minus 2. Oh, wow, looks like I'd be able to factor that. So this will be the 2x and x minus 2. So that will be plus 1, plus 2 here. You factor, this is plus 2 minus 1, right? So it will give you the, so it's plus 2 minus 1. That's what it will give you the 3x here. It's a factor. Okay, good. So I know this one's here. I'd be able to factor out as what? As the, so this is x squared plus 2x minus 1. Then this is x, 2x minus 1, x plus 2. Okay, so my denominator is the linear form of the factor. So I can factor each one, like this one's here is x, and so you have 2x minus 1, and you have x plus 2, right? So each one you can pull that out. So I have x plus 2x minus 1 plus x plus 2. Right? So that's what we talk about. You can break it in here. Then here, you put 1 degree less. This is the first power. So you put a constant. It's A, B, C. Correct? And now, the only thing I need to find is what is the value of A, B, and C. After I find it, then the integration will be pretty straightforward, right? Will just be done, you know, the natural log because it's on the bottom. So let's see what is ABC here. So here, this is where it's kind of become tedious here, right? So first, what is the common denominator? This is 2x minus 1, x plus 2, right? So you have 3 variables. So you will need to have 3 equations to solve it. So the A, so this is a common denominator. A is under the x. So A is 2x minus 1, x plus 2. Correct? And then the B is what? B is 2x minus 1 here. So I have x plus 2. Then what is the C? C is x times 2x minus 1. Am I right? Okay. Now, the next thing here is a FOIL, right? A FOIL that, okay. So now in here, this is the A. So you FOIL this. This is a 2x squared. This is a plus 4x minus 1. So it's plus 3x minus 2. Then this is B, so this is x squared plus 2x. Then this is C, this is 2x squared minus x here. All right, and now here we'll just be very careful about your algebra, right? So, okay, so let's take a look at what is the term for x squared. Here is x squared, here's x squared, here's x squared. All right, so here's x squared. So I know, so the x squared constants will be what? It's 2a plus b plus 2c, right? So what is 2a plus b plus 2c? You compare with this x squared term. So this is x squared. So what is this one will be equal to? This will be equal to 1. Correct? Okay, now let's take a look at the term with only x. So this is the only x, this is only x, and this is only x. So let's put our second equation will be 3a, right? 3a plus 2b and minus c. So what is the x term going to belong to? You need to compare to this one, right? So what is this one equal to? Is equal to 2. Then the last one here is a constant term. So this is a minus 2. This one doesn't have any. This one doesn't have any. Oh yeah, that's pretty good, right? So this is minus 2. So you will have a negative 2a. And what is this one be equal to? Will be equal to what? Be equal to the negative 1. Okay, so now you have 3 equations and you can solve 3 variables. So this one is here, turns out to be pretty easy. So this one's here from this equation, the a is equal to what? A is equal to 1/2, right? So I assume you know how to solve it. Then you substitute the a here, try to solve for b and c. So in here, I already got the solved here. So now after a is equal to 1/2, b, I've solved it is 1/5. Okay, so b is 1/5, and the c is negative 1/10. Okay, so this is basically you need to solve the system of equations, right? And I assume that you are right now in the calculus class. You know the algebra since you know how to do it. So I'm not going to spend the time show you how to solve the system of equation. I assume you can do that. Okay, so after that, okay, so now this integration will just be, so a is 1/2. So you can say this is 1/2, 1/x dx, plus b is 1/5. So it's 1/5. This is 2x minus 1 dx. And then it's minus 1/10. And this is 1/x plus 2 dx. All right, so now this one is pretty easy now. Okay, so now let's see here. Okay, so this one, the integration, that's just our log integration. So it's 1/2 what? Natural log x, right? And then here, this is the 1/2. And what is here? This is another natural log, but I have a 2 here, so I need to be careful. I need to use the chain rule. So it will be what? 1/2, 1/2, right? Because you need to adjust the constants here. The natural log 2x minus 1, and the minus 1/10. What is here? This is just natural log x plus 2 plus k, right? So now your final answer, this is the 1/2 natural log x plus 1/10 natural log 2x minus 1 minus 1/10 natural log x plus 2 plus k here. Okay, so the key things here is this is really is the algebra part, right? So this is the whole distance here is the algebra, right? So how did you find the common denominator? And then how did you compare the corresponding term and then set up the system of equations? So you need to be very, very careful about your algebra skills here, right? So you don't want to mess up that. All right, so let's take a look at our last problems here. Whoa, this problem, let's see here. Okay, so like it's another very tedious algebra part. So this is x4 x cubed. Whoa. Okay, so the top is bigger than the bottom. So what I need to do, I need to long divisions, right? So this is x4. I need to save a space for x cubed. Then minus 2x squared plus 4x plus 1. Now here, this is x cubed minus x squared minus x plus 1. Okay, so now let's take a look. The first term to match the x force. What I need to have here, I need to have x, right? So x times x cubed is what? X force. So you need to times each one. So x times x squared is what? Minus x cubed. X times negative x is minus x squared. X times 1 plus x. Right, and be very careful about your algebra, you minus it. Okay, after you minus it, so what is this one? 0 minus negative x cubed, so it's x cubed. Negative 2 minus negative, so it's minus what? X squared. 4 minus 1 is plus 3x plus 1. All right, now here this is x cubed, so what I need to have here, I need to have x plus 1, right? So this is x, so this is 1, so because 1 times x cubed is x cubed, so this is x cubed. Then 1 times negative 1, so this is negative what? This is negative x squared, okay? And after do that, and then 1, this is negative x, and 1 times 1, this is 1 here. And so in here, you will have, so what we will have here, so we will going to have, this is this cancel, so 3 minus negative 1, so it's a 4x. 1 minus 1, so cancel, that's good, all right, that's good, all right. So it's simpler than I thought, and so this is what? This is our remainder, right? So this is remainder. Okay, so now let's rewrite this integration. So this integration will be, so the x plus 1, then plus whatever's here, this is x cubed minus x squared minus x plus 1. This is dx, put the remainder here is 4x. All right, so now the next thing is here, we need to take a look, how do I break out the denominator? So I need to find a way to factor. Okay, so the denominators here, this is x cubed minus x squared minus x plus 1, right? Okay, now, oh, well, so not bad, I find a way. So here, these two terms, so you can regroup that. So take x2 out, right? So x squared, so what is it? This is x minus 1, all right? And then for this ones here, I take the negative 1 out. So what is here is x minus 1. Okay, pretty good. So I can factor the x minus 1 out, and this is x squared minus 1. Can I continue to factor? Oh yes, the x squared minus 1. So this is x minus 1. So x squared minus 1, I can factor to the x minus 1, x plus 1. Right, so here I have x minus 1 to the square, x plus 1. Okay, so now I'm going to just move this term down. After we solve it, and then we'll put it back to find the integration. All right, so I know the 4x x cubed minus x squared minus x plus 1 can be, so I have two terms here, right? So this one's and this one's here. Okay, so this is the, we can say this is x minus 1 to the square, x plus 1 to the 4x here. Okay, so remember, if this is repeat power, so this one we can break it like x minus 1. And what is the next one here? X minus 1 to the what? To square, then plus x plus 1. Right? And because they are all linear terms, so I can say this is A, B, C, right? So remember we said you will say, hey, this is the x minus 1 to the square. So the square is higher. So here, why you not put the bx plus c? The reason why is when we find a common denominator, this x term you're going to carry out in here because this is only x minus 1. So you need to times x minus 1 here. All right, so that's why for the repeated term, I just need to have the constants here. Okay, now let's try to find the ABC. So we're back again. So put the common denominator. Okay, so I put the common denominator. So this is x plus 1. Okay, so for the common denominator, okay, so now the A, so this is x minus 1. The common denominator is x minus 1, x. So what I need to times here? You need to times x minus 1, x plus 1, right? Then the B here, this is already x minus 1 squared. So what I need to do, I only need to times x plus 1, right? Okay, so then for the C's here, C is C over x plus 1. X plus 1 is here. So what I need to times here, x minus 1 to the squares, right? Okay, now the next things here is very tedious, like algebra, right? So x minus 1 square, x plus 1. Okay, so this is the A to the x squared minus 1. Then this is the B, the x plus 1. Then this is the C. This is x squared formula, minus 2x plus 1. Okay, so just like we did the first one, let's take a look at the x squared term. So this is the x squared term. This don't have x squared term here. This is the x squared term, right? So I have A plus C. But in here, look at the original, the numerator does not have x squared term. So what is A plus C going to be equal to? A plus C is going to be equal to 0, right? Because it doesn't have x squared term. Okay, so now I can find the next things here, the x terms here. Oh, the x term doesn't have x term here. Okay, here got one x term. Here got another x term. So what is that? So I know B minus 2C is equal to what? Equal to 4, right? So the last term, what is the last term I have here? It's a constant term, right? So this is negative 1. Oh, I got a constant. Oh, I got a constant, all the 3. So this will be negative A minus B plus C. But does the numerator have a constant term? No. So what is this one will be equal to? This one will be equal to what? This one will be equal to 0. So if you solve the system of equations, so I assume everybody here should be very good at solving the system of equation. So you will find that A is equal to 1. All right, so if A is equal to 1, then the C is equal to negative 1. If C is equal to negative 1, then B is equal to what? B is equal to 2 here. All right, okay, so now here the whole integration I can do here, I can carry out. So this one's here, remember we have x plus 1, right? So I have x plus 1 plus A is 1. So plus 1 over x minus 1 plus 2x what? Minus 1 to the square. C is negative, so it's a minus x plus 1 dx. Okay, so now in here I can do, so this is a test your integration ability. So this will be x squared over 2 plus x. What is the integration for this one? That is the natural logs, right? So it's plus natural log x minus 1. Okay, so what is this one here? This one is you can use the U sub, right? So that's why you need to combine all the knowledge you learn. So you can use U sub is x minus 1. So that's du is equal to the dx. So here, this term will become 2 u squared, right? So then you use the power rule. So this one will give you minus the 2, right? And x minus 1 to the negative 1 power. Then here, this one is the natural log again. So it's a minus natural log x plus 1 plus c. All right. So if you want to combine a little more, you can do that. So here I will do it here. This is x squared over 2 plus x. This term, I can make it looks a little better. So this is 2. So this is x minus 1. And then these two terms, this one and this one, is natural log minus natural log will be divided, right? So it will be natural log x minus 1 divided by the x plus 1 plus c. All right. So like you see, you know, we use the whole page to solve this problem. So this one is kind of, it's not hard, it's just very tedious, right? So it's a very algebra test. So you need to be very good at the algebra and be very careful and cannot make any algebra errors. And then basically you do a long division, and then you solve the system of equations, and then you use some fundamental integration formula and find you can get your integration. Okay, that's it. So for these two videos, we talk about how to break out the rational function into a partial fraction, and those are the fraction you know how to take the integrations. All right. So the next ones here, next video we're going to talk about is two special, you know, the integration formula, and we are kind of, you know, it's sometimes very useful, and so we're going to take a look at this ones, the next one. Then the third part is how about if you have a roots function, how do I rationalize that? All right, that's it. All right, so the last will be this topic, how to break out the partial fraction, and how do you find the constants, ABCs, those things. All right, that's it. And nice talk to you, and talk to you our next topics here. Okay, bye.